This is video number 4 for sections 4.1 and 4.2, simplifying using the rules. Now that we have our rules of exponents and our different types of exponents, we are finally ready to tackle the primary type of problem in these sections, and that is simplifying expressions, kind of messy expressions, by using everything that we've learned. Simplifying just means write it better, work it out as far as you can, make it as nice and neat and short as possible. Here are some guidelines that we'll be following. We're always going to get rid of parentheses. We're going to combine bases where we can. We're going to work numbers out as far as we possibly can. And we never leave a negative exponent in the answer. The answer only has positive exponents. I've put the rules over here as a reminder. And so in the first few examples, what I've got for you is I've got 5 problems, each of which relates to one of the rules. And so we'll do 2 things. We'll write the rule number that applies, and then we'll go ahead and work it out. I would very much encourage you to pause the video and try these 5 problems yourself before you continue to watch. Okay, well, let's start with this first example here. Hopefully what you came up with as far as a rule is rule number 5. It is an exact match of rule 5, a base to a power to a power. Rule 5 tells us how to work that out. It says, if you look at the right side of the rule, it says the base stays the same. Well, that was x, so I can leave that alone. And the new exponent is formed by simply multiplying the previous 2 exponents together. Now, if you can do that in your head, great. If you need to write it out and work it out, you can do that too. I've written 8 over 1 to make it look more like a fraction. Let's see, I can see that the negatives plus out. 2 goes into 8 4 times. The only thing left there is the 4, and so the final answer here is x to the 4th. I can't do any better than that. That's as good as I can make it, and it fits with all the guidelines. Okay, example 2. Hopefully you came up with rule number 2. This is the one that we were using earlier a lot, where you want to divide 2 items with the same base. That's what's going on here. Look at it. It's an exact match for the left side of rule 2. Well, the right side of rule 2 says that I can work this out by keeping the base on the top. In other words, there won't be a fraction anymore. And then doing the top exponent minus the bottom exponent. It has to be in that order. That's what rule 2 says. When I work that out, let's see, I believe those minuses plus out, and I end up with x to the negative 4. That's the end of the rule, but that is not the final answer, because guideline D says we have to end up with positive exponents. So as one final step, I will need to get rid of that negative exponent. We learned how to do that earlier. You reciprocate the base, and that allows you to change the sign of the exponent. Here then is the final simplified answer. Let's move down to the third example. In the third example, you should have gotten rule number 4. This is not rule 2. I'm not dividing 2 items with the same base. I have a single division problem that is being raised to a power. Again, identical here to rule 4. Rule 4 says that I can distribute that 1/2 power to each piece. So I can distribute it to the x, and I can distribute it to the 16. Where do we go from here? Well, fractional exponents, remember, is all that stuff dealing with roots. But here's the thing. The only reason ever to go to the radicals, the roots, is to simplify a number. This is an x. I can't work this out no matter what I do. So I have no reason to go to radicals here. In fact, x to the 1/2 is as good as it gets. On the bottom, however, the base is a number, and so I can go ahead and clean that up. Let's see, the denominator here is a 2. That refers to square root of 16. The numerator is a 1. That would be to the first power, which doesn't do anything. The square root of 16 is equal to 4, and so here then is my final simplified answer. Again, don't go to radicals unless you are working out numbers. Let's take a look at the next example. You should have gotten Rule 1 in this case. Rule 1 is the one that talks about multiplying two pieces together that have the same base. So let's apply Rule 1 then to this example. So the base stays x, and then we add the previous two exponents. Again, if you can do that in your head, great. If you want to write it down as a little problem to work out, you can do that too. This could be worse. At least we have a common denominator here. So 3/4 plus -7/4. Add up the tops. That would be -4. Bottom stays the same. That works out to be -1. And then the ending of this problem is kind of similar to the second example. I can't leave negative exponents. I haven't done anything wrong. I'm just not finished. And so at the conclusion, I have to reciprocate the base, which then allows me to change the sign of the exponent. Now, I was about to write a 1 here, but of course x to the 1 is just x, and I want this as short and sweet and simple as I possibly can, so here would be the final answer. All right, one more of these simpler situations. The last example is the only rule we haven't used yet, Rule 3, which is the one about having a multiplication problem as your base and then an exponent on the outside. And if you look back at Rule 3, it's very similar to Rule 4, right, in terms of that distributing idea. It basically says that you can put that -2 exponent with the -3. Now be careful there. These parentheses are mandatory because if they aren't there, then the base is not negative. Clearly, though, the -3 is part of the base. And then I can also distribute it to the x. As far as working this thing out now, I think what I would do next, I have too many negative exponents. I really don't know what to do with this number. This has a negative exponent. So what I would do is I would reciprocate any piece with a negative exponent, which happens to be both pieces. Now, that's going to move that stuff to the bottom. What's going to be left on the top? Well, there's always an understood 1 left on the top, right? The reciprocal of -3 is 1 over -3. So this piece comes to the bottom with a positive exponent. This piece comes to the bottom with a positive exponent. The only other thing I can do is I can square that -3. -3 times -3 is +9. And that's it. The final answer would be 1 over 9x squared. Let's work a couple more challenging problems now. I would say the only thing that makes these more challenging, well, maybe two things. Number one, you have to use more than one rule in each of these problems. And the other tricky thing is there is more than one way you can start. And that's challenging, I think. I'll go ahead and give you what I would do, what I think is the best thing to do. Take a look at this first example here. There's lots going on. It's quite a mess. I suppose the thing that first pops out at me, though, is these giant parentheses with the exponents on the outside, because it makes me think of that Rule 3, the one about if you've got a bunch of stuff being multiplied, and it doesn't matter if it's 2 things or 3 things or 4 things, whatever, the principle is still the same. If you have a bunch of things getting multiplied, you can distribute the exponent, in this case, to all 3 pieces. And I believe I have the same thing over here as well. I have 3 items being multiplied, that 4, the x guy, and the y guy, and I can distribute that exponent to those 3 pieces. So let's do that and write down what we get. Basically, I took each of the 3 pieces from the first parentheses and put a -2 exponent on top of it, and then each of the 3 pieces from the second and put a +1/2 exponent on it. Okay, kind of a big mess. Where do I go from here now? Well, I guess the next thing that stands out to me is I now have multiple cases of Rule 5. The one with 1 base and 2 powers, I have it here, 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 and here. That's the one where the base stays the same and you multiply the exponents together. So this I think I'm just leaving alone right now. The base stays the same, multiply. -3 times -2 is 6. Same thing here, base the same, 3/2 times -2, I'm going to get a negative, the 2's cancel, and I get a 3. Okay, I'm not really worrying about the number right now. This one would be x, and then negative 1 times 1/2 is negative 1/2. And this one would be y, and negative 2 times 1/2 is negative 1. Okay, let's see. I've got some options now. I think one thing that might help me is just to rearrange the order so that all the numbers are together, and then all the x ones are together, and all the y ones are together. So let's do that. Now I notice I've got a couple of situations where Rule 1 applies, here and here, where I'm multiplying two pieces with the same base. I'll worry about the numbers later. Rule 1 is the one that says keep the base the same and add the exponents. So base will be x. I need to figure out what 6 plus negative 1/2 is. Sometimes it's good to just go off to the side and do a little bit of scratch work. 6 plus negative 1/2, let's see, I would have to get a common denominator. It would be 2, so that's going to end up being 12 halves plus negative 1/2, which is 11 halves. So my exponent here is 11 halves. And then same thing here, base stays the same. Negative 3 plus negative 1 is negative 4. I think now I'm at the stage where I would get rid of the negative exponents. I could have done that earlier along, honestly. I mean, it really is kind of up to you, some of the order you do these things. Anybody with a negative exponent is about to reciprocate down to the bottom. Now, don't reciprocate the ones with the positive exponents. This one is fine, and the x one is fine. But the 3 has been bugging me for a while. I'll move it to the bottom, and now the exponent's positive. The y, I'll move it to the bottom, and now the exponent is positive. I am just about done here. Let's see. The numbers have to be worked out. The 4, I'll have to do that radical thing. That would just be the square root of 4. The numerator is 1, so I don't have a power. Don't go to radicals with the x. It's not helpful at all. It makes it worse. On the bottom, 3 squared is 9. I think the only thing I have left to do is take the square root of 4, which is 2. And we have our final answer. Okay, we have one last example to work here. Let me clear myself some room to work it out. This one has kind of a cool trick you can do at the beginning that you might not think of yourself. We know that any base to a negative power can be changed to the reciprocal of that base to the corresponding positive power. Let me write that down. All I did was put the bottom on the top and the top on the bottom. I reciprocated it, and that changed this to a positive 2, which is a lot nicer. You say, well, what about the other negatives? Yeah, I haven't gotten to that yet. I can only do one thing at a time. Maybe now I'll distribute this guy out here. Now, you can combine rules 3 and 4. Everything here is being multiplied or divided. There are 6 distinct pieces, and so you can distribute that 2 into each piece. Let's go ahead and do that. And then again, I have several cases of Rule 5, the 1 base and 2 powers, where I go ahead and multiply the powers. Let me go ahead and do that. I have options now. I could use Rule 2, the one about dividing two guys, where I subtract the exponents. Or, because of all the negative signs, I could fix all the negative exponents first. I think that might be easier. Let me do that as well as work out these two numbers here. The pieces with the positive exponents stayed put. I just moved those couple of ones that had negative exponents. Now I've got a couple of cases of Rule 1 where you add the exponents, and I see I can reduce this fraction here. On the top, I just need to figure out what 8/3 plus 2 is. Let's see, 2 would have to be rewritten 6/3. 8/3 plus 6/3, 14/3. On the bottom, I have the number 4. And then on the x, I'm going to get a 6. 2 plus 4 is 6. You can check the guidelines. This is now fully simplified. Remember, you do have some options. Even at the beginning, I didn't have to do that trick. I could have just distributed this negative 2 to everybody first, and eventually I would have ended up at the same place. Obviously, you just need to practice a bunch, and you will get the opportunity